Hello students, welcome back. In this session we are going to draw orthographic projections of this object. Have made a 3D structure of the same object over here, and this arrow mark indicates this is the front view, and this is right to this one is the right side view, and here it's a top view. Means this would be the front view, this would be the side view, and this would be the top view. So here I have colored the different views. Means looking in this direction, this surface I have highlighted with the orange. So orange is the front view, and looking in this direction, these are the top surfaces which can be seen from the top observer, and this surface we can see in front and top. So I have mixed this black and orange. So your top view is black, and coming to side have highlighted with the yellow. See here, this is the side view, and we don't require any bottom or back view because there is no much details in bottom and back view. Only if we draw the front, side and top, it would be enough to represent these type of objects. So now we are making orthographic projections, and then later we'll making isometric projections. So orthographic view is a 90 degrees view of an object. Isometric view is a three-dimensional structure or three-dimensional view onto a paper. So let us start with the orthographic projections. So this object I am taking a reference, and here the dimensions are mentioned over here. This in front view I'll be considering length, this has width, and this has height. Okay, in front view we can see length and height, length and height. In side view we can see width and height. In top view we can see length and width. Orthographic projections. For this I'll be taking the reference line. I'll be dividing this into three parts because I have to draw the front view, top view and side view. Here I'll be drawing the front view, here I'll be drawing the side view, here I'll be drawing the top view. So the length of the object is 60, height of the object is 35. For getting easy figure, I am taking 1 centimeter gap from reference line here and reference line over here. This is 1 centimeter above, 1 centimeter this side, and this is reference line for side view. So from here I'll be starting the figure. So I'll be measuring the length. In front view I can see this edge, this edge, this, all these lines which are shaded with the orange surfaces. I can see that. Here I can see this surface also, because this is inclined to our view, but it can be seen from top also. So it has a mixed structure, top and front view. So here if I number them, this is 1 surface, 2 surface, 3 surface, 4 surface, 5 surface, 6 surface. Means in this front view I can see the total 6 surfaces. So let us take example LHS and RHS. So this can be the LHS. Right now I am drawing here RHS, 6 faces. So this is the length 60, and height is 35, So this length is 60, height is 35, and this width is 10. This width is 10. This width is also 10. And this length is 30. This length, this length is suppose this is 60 mm, and here in between we have a hole of 15. So it would be 60 minus 15, that would be 45 by 2, that would be 22.5 mm. So this length would be 22.5 mm. So I have drawn this, this and this. This one and this one. Next I'll be drawing this surface. Looking in this direction, this would become 10 mm, and this distance is also 10 mm. So I have drawn this too. Next I have remained with this one. So this length from here to here, it would be 15, and this distance is also 15, and this is also 15. This is 15, and at the center I have to locate the 15 over here and 15 over here, this side. So 15 by 2, it's 7.5. And I have to join this. So here we have finished with the front view of this object. Here you can see this one, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6 surface, 6. So let me name them 1, 2, 3, 4, 5, and 6. Totally we have 6 faces in front view. Next I'll be projecting that. This is the front view. I'll be projecting this top view. For this I'll use projector lines. From each and every corner I have to draw the projector lines to the top view. From this corner, this corner. I think we have finished the drawing from each and every corner. There's a projector line. Now coming to the top view, we can see this, and all these surfaces. So the width, look from top, is 35. So same here, I'll take 1 centimeter gap over here, and I'll start the figure from here. Looking in this direction, I can see this whole line, and here also I can see this whole line, but here coming to length I have this gap. Where is this gap? Down to this face, second face. There is a length, width, length, and here we have this gap. So I'm leaving this and starting from again here. So coming to this width, because we are considering this as width, this width is 15 mm. So from here I'll take 15, this is 15, 15 and 15, right? So in top I can see this surface, whole line and this lines. So this is also 15, sorry, this width is 10. This is 10 mm, this one, and from here to here it is 15, from here it is 15, 15, 15. See, from this edge to here it is 15, and this is also 15, this is also 15. Whenever you draw one of the view exactly, then we can follow the projector lines and remain with only one of the dimensions in another view. In front view we have finished with the length and height, so already length is there in the top view, so only we have to keep mind about width. So this is width, this is height, this is length, this is length, this is length, this is width, right? Next we have to draw this surface that can be seen in front and top as well as. So to this end, from here we have this. So from here I'm drawing this, from this. Next from this surface, right? Counting the surfaces in top view, this is 1, 2, 3, 4, 5, 6, 7, 8. Here you can see 1, 2, 3, 4, 5, 6, 7, 8. So I'll be naming them A, B, C, D. A, B, C, D, E, F, G and H. So A, B, C, D, E, F, G, H. This is about top view. Next, for the side view, I have to draw the projectors from top and front view. From each and every corner I am drawing the projectors. So while drawing the front view, we had drawn length and height. Here we have a flexibility of taking the length from the front view. Here we have a flexibility of taking the height and width from the front view and from the top view. No need of measuring any of the dimensions. Just for the intersection of front view projectors and top view projectors, we can draw the side view. For drawing the projectors from top to the side, we have various methods. Simply taking this as center, measuring this length, we can draw arc like this, or else drawing 45 degrees line like this, then joining this projector to that line and from that point to the top. But it would take more time for that. So for easy method, take 45 degrees like this and keep it this and draw arc. See here, if we use arc or this method, that would be joining directly to this point. Now join these projectors to this. Now, looking from this side, I can see this structure fully visible, but this structure and this structure are not fully visible. So we have to draw for that in a hidden lines manner. We can't see this structure, and this structure, so we have to draw that in a hidden lines. So here this is the structure, means up to here we have to draw the hidden lines. This is the structure. Next, we can't see this, so we have to draw that hidden lines. And we can't see this also, that is this surface. Finish the orthographic projections of this object. I'll be mentioning the dimensions over here. We have to mention the dimensions here, here, or here, or here. Don't keep any dimension between the projector lines over here or here. Here or here. We have to keep outside the figure. I'm drawing the dimension lines outside. Maintaining the 10 mm gap between the dimension line to the surface line. This is 10 mm, 15, again 10, this is 15, 15, 15, and this 7.5, 7.5, total is 60, or else I'll mention the dimension over here, total 60. This is the length. And this is the width. This is 10 and this is 25. And coming to height, it is 35. So up to here it is 10. From here to here and up to here it is 10, and rest of is 15. So total 35. This is the height, width, length, and this is your orthographic projections. In this way we have to draw the orthographic projections for this objects, for the hidden lines and fully visible lines. Now we'll be drawing the isometric projection for the same object over here.